In this chapter, we're going to look at how our number system works. We have what's called the place value number system. How does it work? And we're going to look at the National Council of Teachers of Mathematics standards about how to teach things like this. We should teach the meaning of mathematical operations through the use of physical materials, understanding of our number system, particularly group value, grouping, and place value. So what does all that mean? Well, let's think about how the number system works. We have what's called the base 10 number system. It's also called the Hindu-Arabic system. In this system, there are 10 different symbols or digits to represent quantities. And here they are in red: 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. In fact, there's nothing special about having 10 different symbols. In fact, there are number systems in use that use a different number of symbols. A prime example being the binary number system, which only uses 2 symbols, 0 and 1. Octal number system, which uses 8 symbols, 0, 1, 2, 3, 4, 5, 6, 7. And also hexadecimal, which uses 16 different symbols, the digits 0 to 9, and then the letters of the alphabet A, B, C, D, E, F. Throughout history, there have been other number systems around. For example, the Egyptians had their own number system using just 7 different symbols. And here they are. One is shown with a single stroke over here. 10 is shown by drawing the hoof for cattle. 1000 is shown by drawing a coil of rope. And 1000 is drawing of a lotus plant. 10,000 by a finger. 100,000 by a tadpole or a frog. And 1,000,000 is a god with his arms raised. Here's an example of a number, 3,244, written in the Egyptian number system. And below that, you'll see 21,237. But in our Arabic number system, we have 10 different symbols, but these have evolved over time. So these little diagrams will show you what these symbols look like in the past, beginning with the 1st century AD, going to 969 AD, a little bit closer to what we're used to, and finally in the 11th century AD. Other symbols in history: this is the Mayan number system, using only 3 symbols, a dot, a bar, and then a symbol for 0. And here are some sample numbers written in that system. So how do you think numbers arose? To understand how number systems work, let us imagine that we are cave people and that there is no number system. So how would you communicate how much you want of something? Well, here's an example. You can just basically show I want this much. You'd need an object for every number. But of course, once these numbers get very big, this becomes kind of cumbersome. So the first simplification is to start grouping things, or replacing a certain number by a symbol when we get to that quantity. The number of objects for which we group is completely arbitrary. So the number of different symbols is called the base. And we need symbols to represent objects up to that point, and then we group them. So as an example, let us imagine that we group whenever we have 6 objects. That is, we have what's called the base 6 system, or we have 6 different symbols. Here they are right here, 6 symbols. No other symbols exist, and we need to use just these 6 to be able to write any number at all. How are we going to do that? Well, let's see. If we have nothing, like over here, we're going to use our first symbol, right here, the first one. If we have this many objects, then we're going to use this symbol. If we have this many objects, we will use this symbol. If we have this many objects, we will use this symbol. If we have this many objects, we use this symbol. And if we have this many objects, we will use this symbol. Now, if we add one more object here, how are we going to write that object? Don't forget, there is no other symbol for 6 objects. So think about it, stop the video and think about it, how you would write the next number. So we've arrived at this point, and we are now adding one more. And we're thinking about how we're going to write this number. Well, we can't. We don't have a symbol for it. So what we're going to do is we're going to group these together by connecting them and making a group of 1, 2, 3, 4, 5, 6. And from now on, we're going to use 2 columns. This column here for number will tell us how many 6s we have. And so it'll tell us how many of these we have. And how many extras do we have? Well, we have one of these and no extras. If we have that many. Now, if we keep adding, we'll have one of these and 1 extra. One of these and 2 extra. One of these and 3 extra. One of these and 4 extra. One of these and 5 extra. Now if we add one more, so this many objects, we have now one group of 6 and 5 extra. If we add one more, how do we write the next number? Well, again, we make a group of 6, place it here into this column, and now we have 2 groups of 6, not 1. And none here. If we keep adding objects, we have 2, 1, 2, 2, 2, 3, etc., etc., etc. We keep repeating this process. Eventually what will happen is that we will have this many objects. We'll have 5 groups of 6 and 5. So we write that as 5, 5. Now, if we add just one more object, how are we going to write how much we have? Stop the video and think about what would be the next number. So, there's no symbol for this many objects here. So what we're going to do is we're going to make a group of 6 out of these, add that on here, and because we don't have any 1s in this column, we're going to write 0 here, no 1s. But we don't know how to write this many groups of 6. So what we're going to do is we're going to group all these 6s. Now there's 6 6s here. 6, 1, 2, 3, 4, 5, 6. We're going to make a group of them. We're going to make a group of them if we can here. If we didn't mess up a bit here. Okay. We're going to group them. And we're going to add a 3rd column now. This 3rd column over here will tell us how many of these we have. And so right now, there's none here, none here, and one group of 6 sixes here, or 36s. 100 would be the next number. So the place values for this base are, whatever digit is here tells you how many of these there are, ones. Whatever digit is here tells you how many of these there are, sixes. Whatever digit is here tells you how many of these there are, and these are 36s. So the place value in base 6 are like this. For example, supposing we have a number 253 in base 6. Now this is not 253. This is in base 6. How much would this be in base 10? Well, 3 of these, 1, 1, 2, 3, 5 of these, 1, 2, 3, 4, 5, and 2 of these. 1, 2. How much is that total? Well, we have 2 36s, which is 72, plus 5 6s, which is 30, plus 3 ones. So the total number would be 72 plus 30 plus 3. If we were working in base 5 instead of base 6, then the place values would be multiples of 5. This digit will tell you how many of these there are, ones, just like in base 6. But this digit, whatever it is, would tell you how many 5s there are, how many of these there are. And this digit will tell you how many of these there are. So let's stop the tape and see if you can answer this question. The number 255 in base 6 is how much in base 10? To answer this question, you must remember the place values. So the place values in base 6 are these. So 255 means 2 of these, 5 of these, and 5 of these. 2 36s, that's 72. 5 6s, that's 30. It's 102. And 5 1s, that's 107. So that would be the correct answer. 2 times 36, 2 36s. 5 times 6, 5 6s. And 1 times 5. Add all these up and you should get 107. Going the other way, imagine we're going the other way. Supposing you had 81 objects, that means this is 81 in base 10. How would you write this number in base 6? So in order to do that, you have to remember the place values for base 6, and here they are, 1s, 6s, 36s. So if you had 81 objects, how many of these can you make? How many groups of 36 can you make out of that? Can you make at least one? Yeah. Sure, you can make one. Can you make 2? Yeah, you can make 2. Can you make 3? No, you can't make 3. So you can only make 2. And if you make 36s, that's 72, you would have 9 left over. Out of that 9, how many of these can you make? You can make 1. And how many would you have left over here? You would have 3 left over. So you can make 2 groups of 36s, leaving 9. Out of the 9, you can make 1 group of 6, leaving 3. and you have 3 left over at the end. So 81 in base 6 is 213. Or 105. So once again, let us try a problem. If you had 90 objects, how would you rate this number in 36, in base 6? So again, you have to know the place values for base 6. Get this a little smaller. And here they are. So if you had 90 objects, first of all, how many groups of 36 can you make out of that? Well, you can make 1, you can make 2, but you can't make 3. Now, if you made one group, two groups of 36 out of 90 objects, how many would you have left over? Now, 2 times 36 is 72, so you'd have 18 left over. Out of the 18, how many groups of 6s can you make? 3, and there'll be none left over. So, how to write 90 in base 6? You would write it as 230. If you were working with some other base, then the place values would be multiples of that base. For example, in base 5, this digit would tell you how many 1s there are. This digit would tell you how many of these there are, 5s. The next digit would tell you how many of these there are, 5 5s or 25s. In base 4, the first digit tells you how many 1s there are once again, but this next digit tells you how many 4s there are. And the next digit tells you how many 16s there are. And of course, in base 10, we have 1s, and this digit tells you how many 10s there are, and this digit tells you how many 100s there are. So this leads us to how our number system works. As an example, supposing you had the digits 1, 2, 3. How much would this be in base 10, in base 5? Well, the 1 here means one of these, 1 5, 125. 2 of these, 2 5s. And then 3 1s left over. Add all those up, and you will get 38. So 1, 2, 3 in base 5 is 38 in base 10. How about 1, 2, 3 in base 4? Well, that would tell you there are one of these, 1 16. Two of these, 2 4s. And 3 of these means 3 1s. So 16 plus 8 plus 3 will give you 27 in base 10. So 1, 2, 3 in base 4 would be 27. Of course, in base 10, it would be 123. So let's see if we can do this. The number 221 in base 4. How much is that? Stop the video and see if you can answer that. To answer this, we need to know the place values for base 4. Well, we just went through it. 221 means 2 of these, 2 of these, and 1 of these. So 2 16s, 2 4s, and 1 more. 2 16s is 32, plus 8, plus 1 equals 41. Here you'll see the answer, 41 in base 10. If we went the other way, if we had 47 in base 10, how would you write this in base 4? Stop the tape and see if you can answer this question. In order to answer it, you would need, again, to know the place values. We had 47 objects. 47. How many groups of 16 can you make? Well, imagine we have 47 objects, like I have here. So how many groups of 16 can you make? So here's one group of 16, another group of 16, that's 32, and you can't make another group if you have 47. I don't have enough for another group, so you can make two groups of 16. Now, if I make two groups of 16, this is what would be left right here. Out of this, how many groups of 4 can I make? Well, you can see 1, 2, 3 groups of 4. And how many are left over? Well, you can see there are 3 left over. So 47 in base 10 can be written as 232 in base 4. Again, to get that out of the 47, how many groups of 16 we can make? 2. How many groups of 4? And how many ones left over? And we can see the answer to all this is 233. I made a mistake here. Yes, at the end we have 3 left over, so it's 233. Just checking if you're paying attention. And of course, in our base number system, the place values are multiples of 10. So this tells you how many, this first digit tells you how many ones there are. The next digit tells you how many of these tens there are. The next digit tells you how many of these 100s there are. And the next digit will tell you how many of these 1000s there are. But just as we learned how to work with these other bases using manipulatives, so your students need to work with base 10 blocks to learn how our number system, base 10 number system works. Now, you're not going to teach your students all these other bases. We're just doing it for practice so you can understand the value of using manipulatives